Okay. So basically, this is a conversion between cubic meters and cubic centimeters. So our original quantity is 1 meter times meter times meter. And so we're going to multiply by 100 centimeters over 1 meter. That cancels one of those. And then same thing again. And then there's still one left, so one more time. Now all the meters are canceled. The only units you have left are centimeters times centimeters times centimeters. And 100 times 100 times 100 is a million. So a million cubic centimeters. Any questions about that one? Okay. The next thing I want to talk about is scientific notation. And the idea of scientific notation is that any number can be expressed as one non-zero digit and then a decimal point, and then the decimal part, times 10 to some integer power. So an example of that is the number negative 3,461.45 is equal to negative 3.46145 times 10 to the third. A lot of times as a shorthand, I'm going to write this as negative 3.46145 capital E3, because that's how you enter it into calculators a lot of times and stuff. And it's fine with me if you use this shorthand, but one thing I just want you to notice is that is not the same thing as negative 3.4. Why did I put so many numbers in this? 6145 e to the third. Okay, this is a number, but it's not the same as this number, and that's because e to the power of something, this means, you know, this is negative 3 point whatever times 2.71 and on and on. That's what that lowercase e means, to the third power. Okay, so if you want to use that shorthand, just don't write it like this. Okay. Yeah, that's fine. Yeah, I can make sense out of that. Another example is 0.0000815 can be written as 8.15 times 10 to the 1, 2, 3, 4, negative fifth. Or 8.15 e minus 5. So in that shorthand, notice, so there's two things the way I'm writing this. I'm using a capital E for one thing, and the other thing is that I'm writing the exponent in line with the other numbers. I'm not writing it up as like a power of E. You know what I mean? Using scientific notation, the idea of significant figures, like significant figures can be a little complicated trying to remember all these rules. But if you write your number in scientific notation, it's automatic. So we're not going to use significant figures, but I do want to just say write the number in scientific notation. Then the number of digits before the times 10 to the n is the number of significant figures. So instead of remembering like 5 rules or whatever, it just sort of automatically happens for you. This means in this first example, how many significant figures are there in negative 3,000, so on? There's 1, 2, 3, 4, 5, 6 significant figures. And in the second one, there's 1, 2, 3 significant figures. Okay. Any questions about that? Okay, so in order for us to express things with scientific notation and to make sense out of stuff that we're given in scientific notation, we need two methods. We need one to take a number that's in standard notation and write it in scientific notation, and one to go the other way. So the first one is to put a standard number in scientific notation. And I'm going to do this, well, I'll go first, I'll write the steps and then I'll follow it through with an example. So first, A, count the number of places to move the decimal point so you have one non-zero leading digit. And did you move the decimal point left or right? Okay, so let's say that we're, as an example, I'm going to use negative 541.6. Okay. How many steps do I need to move the decimal point so there's one non-zero digit before the decimal point? 2, and to the left or the right? Yep. So move it 2 to the left. Oh, and let's say, so count the number of places. Let's call this number of places n, okay, capital N. So in the example, n is equal to 2, and you move to the left. And so now, the second step is, if you move to the left, then you're going to multiply by times 10 to the n. If you move the decimal point to the right, you're going to multiply by 10 to the negative n. Okay? And that's all there is to it. So in the example, n was equal to 2. We move to the left. So we're going to have negative 5.416 times 10 to the positive 2. Any questions about that? Okay, the second method is to express a number in scientific notation, in standard notation. And for this example, I'll use 6.52 times 10 to the minus fourth. We want to express that in standard notation. So read the absolute value of the exponent n, and the sign of the exponent. Okay, so in this example, n is equal to 4, and the sign is negative. Okay. Step 2. If the sign was positive, move the decimal point n places to the right. If the sign was negative, move the decimal point n places to the left. In our case, the exponent was negative, and so we're going to move the decimal point to the left. Our original number, so think of it as like we have 652. Okay, we're going to move the decimal point from here 1, 2, 3, 4. That's the new decimal point. All of these empty places need to be filled by zeros. And so our new number is 0.000652. Or that's the same number, but expressed in standard notation. Any questions about that? Oh, one thing that you should keep in mind, and I guess this is the last thing I'll say. So notice you need to be careful using standard notation when you have really tiny numbers. For example, if you have the number 0.0012345872. Okay, so say that's your number. Okay, it might seem, it looks reasonable, may look reasonable to round this to 0.00009, right? I mean, it's such a small number. You've only changed the number, you know, 0.000028 or whatever. It doesn't seem like much. But the thing is, in our calculations, we're going to be multiplying numbers most of the time. And so what you've really done is you have increased the value here by a significant percentage, you know, like over 5% or about 5% by rounding this to this. Do you understand what I mean? And that 5% is going to get propagated when you multiply that number to something else. So it, like, when you write really small numbers in standard notation, it's a lot more sort of enticing to do round offs like this. If you think of it as 8.72 times 10 to the, what was it, 1, 2, 3, 4, 5, 6, minus 6. It's kind of, I don't know, to me anyways, it's more intuitively obvious that rounding this up to 9 is changing the percentage of your value a lot, and it's going to affect the answer significantly. So, and I think maybe the reason that it seems more enticing to round it off if you're writing in standard notation is because you just have to do so much more writing. Like, you're tired by the time you get to the number, you know. Okay. Anybody have any questions about any of that? So the last thing we have to do that we'll start with next time is I want to talk about prefixes, micro, milli, centi, how to do conversions between those, millimeters to meters to kilometers, that kind of thing. And that's pretty short. And once we're done with that, we'll move on to kinematics and actually describing motion. Okay, thanks.